Hello and welcome to this video. Today we're going to be talking about how to choose the optimal number of clusters in a k-means cluster algorithm. So in my last video we talked about how to determine the clusters, which we're going to build on top of today. But if you remember, with k-means clustering, you use a predetermined k value, k being the number of clusters. So how do we choose that value, and what's the best number of clusters for a model? Well, the best number of clusters is going to have the least amount of variance. And so one way to do that is to create those clusters and then calculate the variance and keep creating the clusters, going up by one each time. So starting at 1, going up to 2 and 3 and 4, etc., and determining the variance. Whichever one has the lowest variance is the one that you want to use. Now there's a little bit of a catch to that. I'm going to go over it as we walk through these examples. So let's start off with k equals 1. All right, and remember k is the number of clusters. So I'm not going to go through the specifics of how to determine the clusters because I did that in my last video. But essentially, we're looking at one giant cluster that encompasses all of the data. Now, the variance for this is going to be huge because we only have one cluster. So, and as we do this, I'm going to track the variance, or the reduction in variance rather, through what is called an elbow plot. So let's look over here at this crudely drawn plot. This is going to be the reduction in variance, and this is going to be k, or the number of clusters. Starting off with 1, and then going to 2, and 3, 4, and 5, and 6, and whatever we need. So here we have k equals 1, and we know the variance is huge. So we're starting right here, right? Because this is not the variance, but the reduction in variance. How much does the variance decrease each time we add another cluster? So I'm just going to copy this data set and do another one for k equals 2. Yeah. So this one will have two clusters. All right, and I'm just going to estimate. So something like this. And normally they wouldn't overlap like that, but that's okay for the sake of the example. Now, we can kind of visually see that the variance is going to be less than this model where we just have one cluster. So let's say it actually dropped by 50. So now the variance is 50, and going and looking at this elbow plot, and now we're on this k equals 2 portion of the x-axis, and let's say right here is 50, okay? So the reduction went from here to here. So that's a pretty steep reduction. So we'd say that's pretty good. We definitely want to have at least 2 clusters. Now let's try a third. All right, so this one is k equals 3. And again, I'm just going to kind of estimate these. Now looking at these, you probably are going to have a smaller variance. And let's say we reduce by 25. So going back up here to this elbow plot for k equals 3, we see that there's still a pretty significant reduction, going from 2 clusters to 3 clusters. So from that, you can say, yeah, we probably want to have at least 3 clusters. I think you see where this is going now, but let's do number 4. Let's do k equals 4, so 4 clusters. Again, I'm just going to kind of draw these like this. And pretend that looked better. Let's say our variance actually didn't go down that much. Let's say it went down by 2 this time. So variance equals 23 now. Now going back up to our elbow plot and looking at k equals 4, it only went down 2. So based on this graph, that probably doesn't even look like it went down at all. So now we can see this pivot right here. This is why they call it an elbow plot, because this is where the optimal number of clusters is. It's where it stops being worth it to add more clusters. Because remember, it's the classic bias-variance trade-off. The more clusters you have, the more bias there's going to be, and we don't want bias. But also the more clusters you have, the less variance you're going to have. So it's that sweet spot where, yes, from 2 to 3, you're adding 1 more cluster. It was totally worth it because our variance went down a lot. But then going from 3 clusters to 4 clusters, probably not worth it because the variance went down a very small amount. So then we know our optimal number is going to be 3 right here. And that's kind of the basics in how to determine the optimal number of clusters for the k-means cluster model. Thank you.